So today we're going to be looking at finding the area of irregular shapes, finding the area of compound shapes, and how we're going to look at that is actually a few different ways. So we're going to take this shape here. We're going to label these sides 5, 6, 2, 5, 4, and 10. And one of the basic ways that we're going to go about doing this is breaking up the shape. So there's a couple different ways that we can go about this, but one of the things that we can do is break up the shape. And so we're going to draw our imaginary line here that breaks up our shape right here, and we're going to look at these two shapes as different shapes. So here we have a 6 by 5 rectangle, and here we have a 5 by 4 rectangle.
How do you know what numbers to use?
Okay, so we use 6 times 5 because it is the area of a rectangle, length times width, and that also works with squares as well, okay?
Okay.
So here we have 6 times 5, which is
30.
okay, and we add that to our 5 times 4, which is
20.
right. Okay, perfect. So our area is 50, and if we were giving this, say, inches, what would our units be?
Inches squared.
Right, inches squared. Okay, and that's anything with area has the squared, has the little 2 on top of it. Okay, so that is one method that we can do to find the area of this odd shape. Another thing that we can do, I'm going to give us the same shape, 5, 6, 2, 5, 4, and 10. What we can do is draw an imaginary line out and find the area of this entire box. So what would the length and width be of this whole box?
6 by 10.
Perfect. Okay, and then we're going to find the area of this imaginary box that we created. So what is that?
2 by 5.
Yes, perfect. 2 times 5. Okay, so now, same process, except here, where we added our 2 individual shapes, we are going to be not using this shape. So when we have 6 times 10 is, correct,
60.
If we wanted to get rid of this shape, what is an operation that we'll get rid of?
Subtraction?
Perfect. Subtraction. So 2 times 5 is then 10. And we can go ahead and go with 60 minus 10 is 50. And let's say we gave this feet.
Feet squared.
Perfect. Feet squared. Okay? Another thing that we can do, which is a little abstract, but it's actually pretty neat, is if we go down here and we draw our shape. And we give it 6, 5, 2, 5, 4, and 10. And here's what we do. We imaginarily draw this shape flipped on top of that shape. And it's a little weird when you first started, but let's imagine that this is the small edge, this is the big edge, here's another small edge. So if this is a small edge, what would this size be?
4.
Perfect, 4. Okay, so what does that make this? If this is the long edge and this is the long edge,
6.
would make it 6. So now I want to know what's my total length of this side.
6 plus 4.
6 plus 4, which is
10.
10. Perfect. And now we have a 10 by 10. Okay, so 10 by 10 is 100. And then here's what we're dealing with. This is the shape, and this is another of the same shape. So here we have 2 shapes happening, but only one of those shapes is the shape that we're trying to find. We're trying to find this area, and currently we have all of this area. So if we have 2 shapes happening at once and we only need half of it, we only need one of those, how could we get this 100 to be half?
Divide it?
We could divide it. Okay, so we divide by 2, And if you think about it like money, $1 divided by 2,
50.
50. Perfect. Okay, so if we gave this meters, for instance,
Meters squared.
meters squared. Okay, we're going to look at one more example so that you can get some practice with it. Okay, here we have a 2 by 2, and we are going to be trying to find the shaded region, our box inside. Okay, and so one of the things that we need to remember is how our geometry of triangles works, and so if we wanted to break this up into the sides of our triangles, and we know that this is halfway, then we need to find out what this side is when this whole thing is 2. Okay, so what's one piece of our whole thing?
1.
1. Perfect, because that's half of 2. So this is also going to be 1. Okay, now we can say that because this is 1 and this is 1, we need to know a little bit about geometry and how triangles work. But if we wanted to go into it, no, that's not what I thought it was going to be. Okay, so we're going to backtrack a little bit. That's actually going to be the square root of 2, which is not something we're 100% familiar with, but we're going to do something cool. So all of these are going to be the square root of 2. Okay, and our area formula says, even if it's a square, it's length times width. Our length and our width are similar, they're the same thing because it is a square. And now, we have to remember one of our algebraic rules, that when we are timesing two things that are squared, it's kind of like squaring it itself. And if we were to say that, if we were to look inside and say 2 squared, that would be 4. And then if we square rooted 4,
that's 2.
we get 2. Perfect. So it's kind of like this and this cancel each other out here. Okay, and we've done our length and our width, and this is actually our area of our shaded figure. Okay, so it's a little complicated, but we just have to remember some basic rules. This is the Pythagorean theorem. A squared plus b squared equals c squared. Okay, to end up finding our other side. But then once we do that, it's a pretty simple algebraic term.